Hello engineers, welcome to Craze Control Automation. I hope you are all doing good. It's been a while since we all met here. Today we are going to look at PLC programming. PLC programming, the meaning of PLC, the function of PLC in an industry, the job that PLC does. We are going to look at how to program PLC, right? So today we are going to look at the PLC hardware configuration. Alright, so if you want to stay tuned and also get this video to watch always, then I would like you to subscribe to this channel. And then you hit the bell icon, you select all to receive all the notifications of videos I'll be doing. And then you like the video. Alright, you share the video to your friends, you put down your comments, whatever that you don't understand, let me see it in the comment section. So now let's continue. Today, I said earlier, we are going to look at the PLC hardware configuration. The hardware configuration. So let's see the definition of a PLC. What is a PLC? Or what is PLC? PLC is an industrial computer control system that continuously monitors the state of input device or input devices and makes decisions based upon a custom program to control the state of output devices. Let me go back again. PLC is an industrial computer control system. Alright, it is an industrial control is an industrial computer control system that continuously monitors the state of input devices and makes decisions based upon a custom program to control the state of output devices. Let's look at another definition. A formal definition of a PLC comes from the National Electrical Manufacturers Association, that is NEMA. They are also saying that a digitally operating electronic apparatus which uses a programmable memory for the internal storage of instructions for implementing specific functions such as logic, sequencing, timing, counting, and arithmetic to control through digital or analog input or output models. Various types of machines or processes. Alright, so what they are also talking about is that the PLC is an industrial let's go back here. I'll explain the first one later. You come here. The first one is saying that the PLC is an industrial computer control system. Alright, it means that the PLC works the same way as our normal laptops, our system unit in our houses, in our homes. Alright, but for the PLC, it is installed in an industry to perform the same function as the computer, because it has input and output. That accepts input from outside, and then it will process the information that it has received, and gives out an output. Alright, so PLC takes in an input, and gives an output based on the program that you have installed on the PLC. Alright, so it is saying that PLC is an industrial computer control system that continuously monitors the state of input devices. Alright, so it means that it monitors the state of input devices, and makes decisions based upon a custom program. So when you talk of custom program, it means that you have designed a program, a control program, and then you have installed it on the PLC. So now when it accepts an input from outside, based on it will work based on the program you have made on the PLC, the program that you have designed on the PLC. So the moment it accepts the input, it will go and look for that program that you are saying I should do what. So based on the program that you have installed, it will give you an output. An output based on the program that you have designed. So that is what they are talking about. All right, so let's go to the other one too. Is that okay? Is that a digitally operating electronic apparatus which uses a programmable memory? So now you see, before a PLC will work, okay, the PLC consists of what? Consists of a programmable memory. All right, yeah, for the internal storage of instructions for implementing specific functions, okay, such as logic, sequencing, timing, counting, and arithmetic. So PLC, you can design logic diagrams, all right, sequencing diagrams, timing diagrams, counting, and then mathematic program, that is arithmetic, okay, arithmetic, mathematics. It can perform mathematic functions, yeah, to control, all right, to control, and then through digital or analog input or output models, various types of machines or processes, okay. So before it will be able to perform a function, okay, it will be done through either digital or analog input or output models. So we'll be talking about all these things, okay. So now let's go to the hardware configuration of the PLC, okay. Now we have so many PLC manufacturers out there, right? We have Siemens, okay, we have Siemens, we have Mitsubishi, right? Mitsubishi, we have Mitsubishi, okay. I don't know that I'm okay, I'm through the spelling, okay, yeah. Mitsubishi, we have Oberon, we have Allen Bradley, okay, yeah, okay, yeah, that is Rockwell Automation, okay, yeah, that is for Allen Bradley. All right, we have so many. We have Yaskawa, okay, there are plenty, yeah, there are plenty. To mention a few, there are plenty, okay, but we are going to use Siemens, okay, Siemens, we are going to use Siemens. All right, the PLC that I am using in my facility here is Siemens. All right, yeah, so we are going to learn Siemens PLC. All right, so Siemens is mostly used in Europe. It comes from Germany, okay. The manufacturer is in Germany, okay. So they manufactured Siemens products, so mostly it is used in European countries. And then you have this ones and this ones, and then the Allen Bradley. The Allen Bradley is from the Americans, all right, Rockwell Automation, okay. So in America to find Allen Bradley, yeah. So though you find Siemens also in America, but Siemens is not as much as compared to Allen Bradley. The same when it comes to Europe too, Siemens is much. Though Allen Bradley is also there, but it's not also as much as Siemens in the European countries, okay. So we are going to use Siemens, all right, Siemens, okay. We are going to use Siemens, yeah. So the PLC we have here is Siemens, okay, Simatic Step 7, okay, Step 7 300. So this is the version that we are going to use, Siemens Simatic Step 7 300, okay, yeah. So let's look at some models here. All right, we have Siemens. These are Siemens products, okay. We have S7 200. The S7 means step, okay, yeah, Step 7 200. All right, the S means step, so S7 200, okay. This is their oldest model, okay, that they designed. Though it is in use, but it is going out small. All right, now we have Step 7 300. This is what we are going to learn, okay, yeah, the model that I'm using in my facility, okay. And also in most of the industries you will find this model, all right. And then we have S7 300. We also have S7 400. This is a newer version of this one, okay, yeah, advanced version of this, okay. Though they are all performing the same function, just that there are small differences, okay, yeah. So this is S7 400. And then now they've also brought this thing, okay. Let's have S7 200, S7 300, okay, and then S7 400. All right, and then we have, that is the TIA portal, okay, that consists of S7, okay, S7, right, 1200, okay, yeah, so we have 1500 and above, okay. So these are all models for the TI portal. All right, yeah, TI portal. The TI means totally integrated automation portal, okay. So we have a 7200, 1500 and what have you, okay, yeah. So now we are going to look at step 700, S7300, okay, S7300. all right, yeah, S7300. So this is the PLC Simatic, okay, step 7300 model, okay, yeah, model, yeah. So this is what we are going to learn today. All right, so I'm going to take you through the hardware configuration of this model. All right, yeah. So we have the model that we are going to use, what is CPU, okay, CPU 314C-2DP, okay. So this is the PLC model that we are going to use. All right, yeah. So this is the model CPU 314C-2DP, okay, yeah, 2DP. Now we are looking at installation of S7, okay, S7 300 PLC, okay. Now when we are installing a PLC, okay, yeah, there are some procedures that you must follow, okay. It has its installation procedure. All right, it has its installation procedure, okay. So now what we have is, let me take you through the functions or the part of the PLC before we come here. All right, so let me clean this one, okay, yeah. So now when you talk of PLC, all right, you have something called the power supply. The PLC consists of power supply, okay, power supply. Well, it has a power supply, that is external power supply, okay, yeah. It's not external, like, though it's a power supply designed by the Siemens manufacturers themselves, okay. It is part of the PLC. There's no way you use external power supply like any other power supply for the PLC, no. Yeah, the power supply is also designed by the PLC, by the manufacturers themselves. All right, so the power supply model, let me show you a picture here. This is the power supply we have, okay. You see, it is a power supply designed by the Siemens manufacturers themselves, okay. It is a power supply designed by the Siemens manufacturers themselves. All right, so we have them in models, in types, okay. So this one is PS307, that is 5A. This PS307 is the model number for this power supply, okay, yeah. Then the 5A means 5 amps. It means that the output current of this power supply, okay, the output current of this power supply is what? Is 5 amps, okay. Now let's see, we have DC 24 volts, DC 24 volts. All right, this power supply, okay, takes in 230 volt or 130 volt AC, okay, AC, and then it convert it to 24 volt DC. The output of this power supply is 24 volt DC, okay. Now let's see this one. You see this and number here, you have 230 volt AC voltage selector. This thing means that in case maybe at your premises, at your home, your house, your factory, maybe the voltage you are having there is 230 volt AC, that's single phase AC, okay, yeah. Now 230 volt AC. So now we have this mode selector or voltage selector here, so that maybe if you are using 230 volt AC, you have to open this plate and then switch this selector to 230 volt AC to match that of your power, okay. if you are having 120 volt AC, okay, then you have to switch it to 120 volt AC here to match it. Else, if maybe you are using 230 volt AC and then you select 120 volt here, you are going to destroy the power supply. Okay, you are going to destroy the power supply. All right, so now we are using 230 volt. I am using 230 volt. That is why I have selected 230 volt here. Okay, but it is not on all power supply that you find this. Most of the power supply, okay, they already have one voltage rating, that is 230 volt. This one is not there. Okay, yes, but in this particular power supply model, we have this thing there. Okay, yeah, as I said, most of the power supplies, okay, you will not see this voltage selector there. They've already made it a single voltage. Okay, that is 230 volt AC or 120 volt AC. Okay, depending on the voltage rating that you want. Now we have this thing here, that is the power switch. All right, the power switch. Now it is at the top mode. Okay, meaning it is on. All right. Okay, now in case you want to buy this power supply, okay, in case you want to purchase this power supply, all right, now there are some numbers here. Because of the camera you couldn't see it well. Okay, yeah, they are here. In case you want to purchase this power supply, this is what you must use this number. Okay, you have to use this number to purchase this power supply. Okay, it is 307 dash I forgot the number small. But the last 4 digits is it's like okay, I'll show it clear to you. Okay, I'll show it clear to you later. Yeah, so in case you want to purchase this power supply, okay, that is the number that you have to use. Okay, now okay, then let me show you the inside of power supply. This is how it is. This is how it looks like. Okay, we have the input, okay, terminal here. All right, I told you it's a single phase. It only all the power supplies are single phase. All right, so we have live 1 and then neutral and then our earth. Okay, live 1, neutral and then our earth. I'm using it, live 1, neutral and earth. Okay, now when the live comes in here, okay, the 230 volt AC comes in here, it will convert it to 24 volt DC. So it will take in an input voltage of 230 volt AC or 120 volt AC depending on your power, and then the output will be 24 volt DC. 24 volt DC. Okay, so now let's see here. We have L plus, that is positive 24, okay, volt DC, and then we have the M, negative 24 volt DC. So we have 3 independent output. So they are all the same, the same voltages. Okay, just that they've joined them. Okay, so that in case you want to use 24 for some other work, you can pick it from here or any other place. Okay, yeah. So this is 1, okay, this is 2, and then 3. Okay, so positive 24, negative 24, positive 24, negative 24, positive 24, negative 24. All right. Okay, so now from here we are going to the CPU. Okay, we are going to the CPU. All right, I told you that we are going to use this model. Okay, CPU 314C-2DP. all right, so now this is it. Okay, so this is the PLC that I am using in my facility here. Okay, yeah, CPU 314C-2DP. all right, so now let me explain this this indications to you. All right, now this PLC, okay, takes in the 24 volt, okay, DC from the power supply. All right, it takes in the 24 volt DC from the power supply. Okay, and then it will also convert it to 5 volt DC. all right, okay, so let's come here. We have system fault, SF. It means system fault. In case there's a fault in the software configuration, in the software. Maybe you downloaded the software program onto the PLC, but there was some error. Okay, it means that this light is going to lit red. It is going to lit red. This is bus fault. In case, let's say, the PLC is working, all right, it is already working, and a fault has been developed in the bus, let's say the Profibus connector, whatever. Okay, this light, or if the communication is not going through well, okay, this light, it is red. Okay, it is lit red. Yeah, you have DC 5 volt, DC 5 volt. I told you earlier that this PLC, okay, or this Siemens PLC, it works, it takes in 24 volt DC. The input voltage it works with is what? 24 volt DC. So the 24 volt, okay, DC output from the power supply, it will be given to this PLC. Okay, so when this PLC also takes it, it will also convert it to 5 volt DC. So you see here, so when the 5 volt DC is okay, this light would lit green. It will lit green. Okay, yeah, let's see here. We have false, FRCE. It is false, but they have shortened it to be FRCE, but it is false. Now what it does is that, in case, let's say you have installed a program on the PLC, okay, and let's say the output of a certain circuit, the output, it is off, the output is off. Okay, you have not switched it on, but you can force that output to be on. Or if it is an input, you can force the input. If the input is in the off state, you can force it to be on, whilst in the program itself it is off, but you can still force it to be on. All right, so the moment you do that, okay, this light, it will let yellow, okay, yellow or orange, okay, let me say, yeah, yellow or orange, yeah, it will lit, okay, indicating that there is a false job going on. Now we have a run light, run. The moment you power on this PLC, okay, this light, it will lit, it is green, it will light green, okay, yeah. And then this one is a stop light. So when the PLC is in the stop mode, okay, it is in the stop mode, you switch this switch, it is called mode selector switch. Okay, so in case it is in the stop mode, this light, it will lit red. Okay, now we have our memory card here. Okay, now if you could remember in the explanation I gave you, I said the PLC, okay, it uses what? A programmable memory, okay, yeah, for the internal storage of instructions. So it means that this memory card, okay, this is where, let's say, when you write a program, okay, on the laptop and we download it onto the PLC, okay, it doesn't go to the PLC, it goes onto this memory card. It is stored on this memory card. So let's say when this memory card, okay, is not in, the moment you run the PLC, it will not work. Okay, it will be in the stop mode. It will not work because the information that it is supposed to retrieve to work on, that information is not there. Okay, so it means that when you program a PLC on a laptop and you download it onto the PLC model, the hardware model, okay, this hardware model, right, it doesn't go onto the PLC. It is stored on this memory card. Okay, so when this memory card is inserted, okay, it is always, it should be in, always it should be in. Okay, so when you put the PLC in the run mode, okay, it will fetch, okay, it will retrieve the information, okay, from this memory card before it will be able to work. All right, so without this memory card, there's no way to work. But some other PLC models, okay, they have this memory card inbuilt. It is not removable. Okay, it is not removable. So in case you want to remove this memory card, all right, you push this button downwards, you just push it in. The moment you push it in, this memory card, it will come out like this, and then you just remove it. All right, yeah. This light here, let me come back here, I didn't come here. We have what? We have run, stop, and MRES. MRES, it means memory reset. In case you want to reset the PLC, just bring it down here. You follow some instructions. Okay, gradually be doing that gradually. So this memory reset. In case you want to put the PLC in the stop mode, you bring it in the middle. Right. In case you want to put it in the run mode, you bring it here. Okay, but this side, here you see the run, it is lock. When you put it to stop, it will lock, it will lock. But when you bring it to memory set, the moment you leave it, it will come back to the stop mode. It doesn't lock here. Okay, so in case you want to purchase this PLC, okay, this PLC, okay, this is the CPU, this is the CPU itself, this is the CPU, this one is the CPU. Okay, so in case you want to purchase this PLC CPU, this is the number, the model number we have to use, 314-6CG03-0AB0. so this is the model number you have to use in case you want to purchase this PLC model, this model. Okay, this model, right? You have so many models, different types of models, right? Yeah, 314 CPU 314C-2DP, the same name. Okay, but if the model number is different, this one is different, it means that the PLC is going to be different. Okay, so now let's go and look at the inside of this here, all right, of this PLC. So that is it. All right, this is it. Okay, so we have this thing here. All right, we have X1. This is the version number of this model. Okay, this is the version number, version 2.0.12. all right, it means it is version 2.0. okay, we have X1, which is MPI, and then X2, which is DP. So this MPI, this is the MPI. Okay, this is the MPI port. All right, and then this is the DP port. Right, let me explain, let me write the meaning of this DP. Okay, so we have the MPI. Okay, so MPI, okay, stands for multi-point interface. All right, multi-point interface, that's the MPI. So what does it do? Okay, what it does is that when we design the program in our laptop, okay, on our laptop, all right, and you want to download it onto the PLC, okay, yeah, we connect, okay, we connect this one is a female, okay, a female port. It is RS232 port. Okay, this is a female port. So you connect an input. Let's say if it's a monitor, you say VGA, yeah, VGA. But over here it is not VGA. It is MPI port. Okay, so we connect the male into it, the male. Okay, and then the other side of the cable will be USB. And then you put the USB in the laptop. Okay, so this is where you download the program. You download the program, or you upload the program from or onto the PLC. Okay, this is where you want to download the program from the laptop or the system unit or the computer to the PLC. All right, in case you want to also upload the program from the PLC to the laptop, you use this same port. Okay, now this port is DP. Right, let me write it here, DP. Okay, it's equal to decentralized. Okay, decentralized. Okay, peripherals, decentralized peripherals. Okay, what it also does is that, right, now in case you have two PLCs or two CPUs, all right, let's say this CPU, okay, yeah, they are two. Okay, let's say they are two. This CPU, let's say they are two, and then you want to join the two together, connect the two together. Okay, so the other CPU should also have this port. All right, the other CPU should also have this port. Okay, so we just connect the cable here. We call it Profibus cable. Okay, just connect the Profibus cable here, and then to the other PLC, the other CPU. Okay, the other CPU, but it should also have the same DP there. All right, yeah, okay, and then we have the input terminal here. So the 24 volt, okay, from the power supply. Okay, the 24 volt from the power supply. Okay, it comes in here. All right, we have the top, that is the L plus, if you can see it here. We have the down, that is the minus. All right, So they've written DC 24 volt here, right? So now we are gradually going. Okay, all right. So now in case you want to install PLCs, okay, in case you want to install PLC, right, let's go to the installation procedures. Okay, yeah, so the installation, okay, yeah, the installation or hardware configuration. Okay, yeah, the hardware configuration. Okay, now we have steps. Okay, we have steps, right? Okay, now we have something called rack 1. Okay, 1. We have something called rack or rail. Okay, so now if you want to install a PLC in your factory, okay, yeah, first you need to have something called rail or the rack. So let me show you something here. You see here, this thing, there's some metal place, okay, yeah, on which all these PLCs are sitting. They are all sitting on this metal plate. So this plate is what you call the rack. Okay, I'll show you clear when we get to the practicals. Okay, I'll show it to you. Okay, yeah, so this is the rack. All right, this is the rack. And then second, you install what you call the power supply. Okay, the power supply, right? And then from the power supply you install the CPU. Okay, the CPU, right? Okay, and then from here you install either IM, interface model. Okay, it is called interface model. Okay, interface model. All right, let's say in case maybe you're going to use a PLC as a slave, some PLC as a slave. Okay, this is where they will come. All right, yeah, either as a slave or some output, some sensors, whatever, in a different location. This is where the communication would also take place. Okay, yeah. So now this or SM, which is equal to Simatic model. Okay, Simatic model. Right, so let's see some configuration here. You see here, okay, in case you want to install the PLC, right, you have to install the rack first. From the rack you install the power supply. This is it. I've seen it, PS, power supply. And then from the power supply you come to the CPU. Though they are saying the power supply is optional, but it is a must. You have to install it. Okay, yeah. And then from the CPU, okay, from the power supply you come to the CPU. That's the second. All right, from the CPU you install the IM. They are saying it is optional. All right, this is the IM, the interface model. From the interface model you go to the SM, the Simatic model. All right, so we have SMDI, and then SMDO, SMAI, SMAO, okay, FM, and then CP, Profibus or Industrial Ethernet. Okay, I'll show them to you. Okay, now I'll explain these things to you right now. Okay, so now they are saying from the power supply go to the CPU, from the CPU go to the IM or the SM. So in place of this you can straight away install this here. From the CPU you come to SM model. Okay, yeah. And even the PLC that I am using here in my facility, there's nothing like IM. I don't have IM here. So from the CPU I came straight to the SM models. Okay, because I'm not using this one for anything. In case I want to extend the location, that is where I will need this. Okay, all right. So now let's see, let me show you something here. You see, before the time we were talking about the power supply, you see here, power supply, we have some number here, this number. Okay, when you buy a PLC new, okay, oh I forgot this thing, there's a disc, okay, that contains all this numbers. It contains numbers from I think from 1 to 30 or so. From 1 to 30 or so. Yeah. So this thing here, okay, there's a small pin here. It's a small pin. There is a small pin. So when you buy a new power supply, this one is not there, but this one is contained on that circular disk, okay, from 1 2 3 up to I think 30 or so. So now, because the power supply is always number one, you remove the one, you just plug it from okay, from the disk, then you put it here. There's a small hole that goes into it, okay. It also has a point, some small points, okay. Yeah, so just put it here to fix it here. All right, so now after that, the CPU should be the second, then you remove the 2 from that disk, okay. I'll show you the disk later. All right, and then you place the 2 here, and you go to let me say the Simatic net. This one's okay, we don't name them the models. All right, then the Simatic net is number 3. So in that order, I'll show you how to go about all these things, okay. So now let me tell you about this thing, the Simatic model, the SM, okay, the SM. All right, the SM, you see, the SM are the digital, okay, the digital okay, the digital input, okay, input and output, okay, output models. All right, models, okay. Yeah, these are the SM models. Now, what do I mean by digital input and output models? Digital input and digital output models. It means that, you see, the PLC, okay, digital means on or off. Digital means, okay, digital means okay, means on or off. All right, or true or false. All right, and then yes or no. Right, and then 1 or 0. These are digital. So our normal push buttons, okay, push buttons, when it is our normally open push buttons, I want to use that one as an instance, okay. Our normally open push buttons, when it is not being pressed, okay, it means that it is off, it is 0, it is false, or it is no, because it is open. But the moment you push it, it will close. Right, it will close and to become what? 1, true. Or in the initial state, if you have not pressed it, it means it is in the off or 0 state. The moment you press it, it becomes 1 or true or on. So now that is where we connect, okay, the switch to. Okay, the PLC has digital input. So all the switch that you are using, our switch, okay, our proximity sensors, they are all digital input devices, okay. So we connect all those sensors, the push buttons, to the digital input model of the PLC. All right, and then you have the digital output model. The output model, okay, it's also over there. So in case we want to control a relay, we want to energize a relay, that's where you connect the relay to, right? So that is what they mean by the SM model. SM means Simatic model. All right, Simatic model. So you can look at this side. Let's see here. Let's look at the power supply. So you have SM digital input. That is SMDI, SMDO. So it means that Simatic model digital input. So this is the digital input. So this is where we connect our push buttons, our sensors to sensors, okay. I mean the digital sensors, digital, okay. Yeah, and then this is SMDO. It means Simatic model digital output, right? So this is where we connect our relay, our bulb, our light, whatever, light, relay, solenoid, whatever. This is where you connect it to, okay. And then this is SMAI. So SMAI means SM, okay. That is AI, means analog, okay, analog input, okay, input. That is the AI they are talking about, analog input. That's the AI. So when you talk of analog input, all right, analog input, okay, analog input means we have, let's say, temperature sensor, okay, or temperature transmitter, or pressure transmitter, or potentiometer, Okay, they are all analog values. They give analog values such as, let's say, let's say 27648. They all give integer values. Integer, analog means integer. So let's say a sensor on the field, a sensor, okay, a sensor, a temperature sensor. Let's say when there is too much heat, the temperature sensor will sense it. When it senses, the output of that sensor is not digital, it's not on or off. It gives reading, okay, from 0 to this number 27648. They are all integer values. So the analog input model of that PLC, okay, will receive this value, okay, yeah, and it will convert it to a corresponding readable value. So let's say in our factories, someone can say, oh, the reading, let's say the temperature value is, let's say 30 degrees Celsius, or the level of the water in the tank is, let's say 5 meters. That 5 meters, okay, you see, it can change from 5 meters to 6 meters when it is going high. It is an example that I'm exciting, okay, I'm giving. When it is, let's say, going up from 5, 6, when the water is going up, the level of the water is going up, it will be changing from to going, let's say 5, 6, 7, 8. You see that value? That value is the analog, okay. So it means that the output from the sensor, it is coming in this form, and then you will program it to correspond to that reading that we can understand. All right. So that's the analog. All right. And then let's see, we have SM analog, okay, analog output. All right. This value, okay, also means that, let's say we want to open a valve, okay, in our factories. We want to open a valve. All right. We want to open a valve, or we want to control a drive, that's VFD, variable frequency drive, okay. So when maybe, let's say, when you input some value on the HMI, our HMI, or on the control room computer, all right, let's say 10, you input 10 and you press enter, the drive would supposed to run at the same value that you have given to it. Or you want to open a valve, okay, to at some percentage, let's say 20%, you enter 20% on the HMI or the laptop or the computer, all right, and then the valve, that particular valve, will also open the same degree or the percentage that you want. All right, so it means that when you input that value there, it will also convert it to an integer value, okay, and it will be sent to the valve. So that is the analog. All right, yeah, that is the analog. Okay, so now let's move from here. They mentioned what, this one, okay. We have FM counting, FM, okay, yeah, FM counting. This counting, let's say we have encoder, incremental encoder, okay, distance, positioning, okay. So let's say you want to count, FM, okay, count FM counting, okay. Let's say you want to count let's say encoder, a reading, let's say doing encoder. There's something called encoder. We have incremental encoder, okay, incremental encoder, all right, encoder, and then we have absolute encoder, okay, yeah. So this one, in case you want to count the speed, okay, the speed, all right. Oh, sorry, this one is frequency model, okay, yeah, frequency model, okay, yeah. So in case you want to count a speed, okay, yeah, a speed of something. So let's say a motor, like revolution of a particular rotation, okay, you have to attach the incremental encoder, okay, to that particular rotating equipment. So as it is rotating, okay, the encoder will also be rotating, okay, and to be counting. So the output of the encoder will be given to this particular model, all right, to this particular model, all right, the FM counting model, all right, yeah. In case you want a position, a distance, a position, you also use this absolute encoder, Okay, so they are very essential in automation, this encoder. All right, yeah. So, and then we also have something called here, let's see here, we have CP. All right, CP. We have Profibus. Okay, CP, have Profibus or industrial Ethernet. So CP it means what? Communication. Okay, communication protocol. Okay, protocol for communication protocol. The CP, that's the full meaning of the CP, communication protocol. Okay, and then we have industrial okay, Ethernet. Okay, Ethernet. Now this one, what it means is that, okay, this switch, in case we have HMI or SCADA, we want to control the PLC through SCADA. So what you do is, okay, you have to attach that that CP, that industrial Ethernet, okay, model to the PLC, and then you use Ethernet cable. Okay, that is RJ45 cable. Okay, you connect it to the laptop or the HMI, so that you can be communicating to the PLC through that protocol, the CP protocol or industrial Ethernet. Okay, you'll be doing all these things gradually. Okay, so I want us to end here. Okay, it's left with this models. Okay, I will explain it to you later. The next video will be on this. Okay, I'll explain the models to you. All right, so let's end here for today. Right, let's end here for today. Okay, so when you are, let me go back once more so that you continue. We will end here. So if you want to install the PLC, first you have to install the rack, your rack on the wall. Okay, on the wall, wherever you want to install the PLC. Okay, so you want to install, you have to install the rack first. From the rack you install the power supply. Okay, from the power supply you go to the CPU. From the CPU, okay, you go to the SM models, okay, the digital input and output models, and then analog input and output models. Okay, and then from there you go to the communication protocol. Okay, there are other models you would install. Okay, yeah, so I'll end here. So the next video, okay, I'll continue from here. All right, so if you want to stay tuned and understand PLC programming, then make sure you subscribe to this channel. Okay, share the video to your friends, you like the video. Okay, whatever that you don't understand, whatever that you think of this programming thing, yes, let me see it in the comment section. All right, yeah, so make sure you subscribe, and then you hit the bell icon, you select all, so that you'll be able to get all the videos that I'll be doing. So now we are going to do intense programming. All right, yes, you connect to the hardware. All right, it is going to be intensive. It is going to be very much intensive. So make sure you all stay tuned to this channel. All right, yeah, it is very practical. All right, I'll take you through all the steps in programming, PLC programming. You connect push buttons, so many things. Okay, so I'll see you in my next tutorial. Thank you.